And what is it that you're doing exactly?
Encrypting all the files. All of Evil Corp's financial records will be impossible to access.
Hey guys, so in today's educational lesson, we're going to do just that. We're going to go ahead and build a data set that's going to have some financial records in there, and we're going to go ahead and encrypt that database.
The encryption key will self-delete after the process completes.
Yeah, we're going to do that too. We're going to go ahead and delete the original database as well as the encryption key.
What about the backups?
I took care of that too.
And we'll leave that for another day. So let's get started. So guys, yes, we are going to actually go ahead and build something very similar to that. Although it may not be as sophisticated as something you'd have as something like eCorp, but at the end of the day, the concept is going to be very similar. Now again, this is for education purposes. Please don't do anything crazy with this. And I should also say the module we're going to use, which is called PySQL Cypher, has no longer been maintained for a couple of years. There are other ways and more sophisticated ways to do this, but maybe we'll leave that for another video. But I thought this is still something that works today, so it's worthwhile showing. And the best part is I did this 100% on my iPad, and I used Code Server, deployed it onto my Linode server, and have been using it since. And the beauty behind it is I can do it on my iPad, come home, jump on my computer, and code exactly from where I left off. And if I want to take a break and stop and hit the road again or do whatever I need to do, I can take my iPad and just continue exactly from there. And the interface is very clean and it's very easy to use. So with that said, let's get started. Alright guys, so here's what we're going to do. I've gone ahead and created a directory called DB encryption, which you'll see down here. And then in that I've created a file called DB Inc for encryption, so DBENC. And that's what we're going to use to do all of our encryption and all of our programming in right here on the iPad. And so when I ls into this directory, you just see I have this one file. Alright, so what are the objectives that we're going to go through today? So first, we're going to go ahead and create a database that has some data, and we'll sort of figure out what that data is going to be. The second thing we're going to do is we're going to go ahead and read that in Python, and then we're also at the same time going to be reading it in terminal, and then we're going to go ahead and encrypt the database, and then finally we're going to go ahead and read the encrypted database. And in both scenarios I'll be showing you also how to use a hex dump function as well. That'll basically show you that the data is in fact encrypted. Alright, so this is the objective that we're going to go ahead and try to achieve today. Alright, so this is also a good segue to let you know that if you enjoy this kind of content, hit that like button, hit that subscribe button, hit that bell notification so you don't miss this kind of content. So for that, we're going to need a couple of dependencies. So first I'm going to bring in from PySQL Cypher import DB API 2. So that's one of the dependencies you're going to have to go and download. I'll put in some instructions in the description to tell you where to get it from. We're also going to need to import OS, and that's because one of the things we're also going to do, so I should put here, once we encrypt the data, we're also going to destroy the original. And I want the original gone from the server, in which case we're going to need the OS module. And then I'm also going to need pandas just to convert this into a data frame, whatever data that we put together. So to start things off, I'm going to go ahead and create a class, and we'll call it encrypt DB. Let's fix that up there. And then I'm going to define my constructor. So we'll say def init, and in this I'm going to have self. But in terms of what I'm going to put here, is this is going to be my connection to my plain text database. So pt underscore connect is going to be equal to SQL Cypher dot connect, and we're going to call this balance DB. So we haven't created the DB yet, or the database yet, but we will very soon. So let's go back and fix this here. So it's going to be called balance DB, and the whole purpose of balance DB is if you are a Mr. Robot fan, you'll see that one of the things that they were trying to do in there was take a whole bunch of data where people owed money and literally encrypt it, get rid of the original so that people didn't owe money, and throw away the encryption key. Now, if you haven't watched all of it, I'm not going to spoil what happens, but at the end of the day, this was the objective he was trying to achieve, and we're going to be doing this using the iPad. All right, so next, let's go ahead and create our database. We're going to say create DB, and we'll put self. I'm going to pass in some kind of data, and we'll create our data in just a second. Data frame is equal to pd.dataframe and we're going to be reading the data in there. And then I'm going to be converting that to an SQLite 3 database, which is pretty standard and popular within Python. We're going to call the table balance table. We'll set the connection equal to self.pt_connect, which is essentially this connection up here that we're going to determine in just a second. If that table exists, just overwrite it, because there's going to be a few times where I may need to go back and recreate it, and I just want to make sure that we're not messing it up. So that's all we need, and index is equal to false. I don't need an index in this. And that is essentially my create DB function. So now let's go ahead and throw some data at this and go ahead and create that DB. So there's another couple of things that I always like doing. So we're going to go ahead and say if underscore name equals main, then run the main command, or the main function, sorry. So we'll go ahead and define our main function here, which is gonna basically tell us what we're gonna be running, but at the same time, it's gonna house the data as well as the class and then the method to that class, which I'll explain in a second. So we're gonna, pipe in some data here. Let me see if I can copy and paste this data that I've had. It's data that I just populated just while I was playing around with things. So let's see if I go paste. There we go. So the data is, in fact, I can copy it, which is great. So what I've got here is I've got 3 different columns. I've got first name, so I've got some characters from Mr. Robot, Elliott, Darlene, Angela, and so forth. I've got their last name, and I've got the balance that they owe back to the bank in this case, or whomever it may be. And what we're trying to accomplish based on what they did in that specific episode was they took the plain text database and they wanted to completely encrypt it with 256-bit encryption and basically wipe out any records. So now that we have data, we have our function create DB, we can go ahead and set e equal to our encrypt database function class. And so we'll just set that equal to that, encrypt DB, and then we're going to go ahead and say e equals create DB, and then I'll put in data as my variable. All right, so now that we pass in the data, we're going to go ahead and try to run this. So again, when I ls, it's only this one file. What you should see on the top left side here is right under dbenc, either above it or below it, you're going to see balance.db pop up, because we're basically creating that. So just to reiterate, what we're doing is we're opening a connection. We're going to say let's open up a brand new database called balance.db, and let's go ahead and insert this information into it, and that's into the table called balance table. And we're basically setting this data, which is all this information here, to an SQL statement. So when we do this in 1 sec, let's go ahead and run python dbenc.py, and now you'll see over here we actually have a file called balance.db. So what we're going to do is we're going to do a few things. We're going to write a statement in a second on how we would read something like this, but let's go ahead and actually type in SQL cipher and then type in balance.db, and that's going to open up an SQLite command prompt for us. So in here we can do something like tables, and it'll tell us that we have a file called balance table. So we can do select star from balance table, and I forgot the semicolon, and you'll see all the data is actually sitting right over here. Now if this was an encrypted database, I wouldn't be able to do this. Alright, so now I'm going to show you a different way to do this. We're going to quit out of the SQLite. We're going to use a command called hexdump. So hexdump is going to show us the hex version of this file. And essentially what we're trying to see is, whether we can see information in plain text. And so when you look at this file itself, you see on the right hand side here that all this information here is actually visible in plain text. If this file was to be encrypted, you will not be able to see this. You'll just see a whole bunch of encrypted data over here that you need a key to obviously go ahead and unencrypt. So now we're going to go ahead and do 2 things. We're going to build another method that's going to allow us to read this through Python, and then we're also going to go ahead and start building our encryption algorithm as well. So let's go ahead and clear this out. All right, so let's go ahead and say define read, and I like to say PT for plain text. We'll give it the pass in self, and essentially this is going to go ahead and read plain text data from an unencrypted database. All right, so that's what this method is going to do. So we're going to go ahead and define our connection as self pt underscore connect, because again we're opening up the new file now, in this case the file that we just created, and we're going to execute a command on it. So we're going to say execute select star from, and we already know it's balance table because we just checked that out. Okay, then we're going to say data is equal to c dot fetch all. And then we're going to go ahead and print out the data that we have, and then finally close the connection. Okay, then we're going to go down here and we're going to change this method to read pt, and then now we're going to go ahead and run this file. And now you see that it actually shows you all the data that is within that database. So basically we created that database, which is consistent of this data, and now it's actually reading it. All right, so the next thing we're going to do is we're going to go ahead and create our encryption function. And to do that, all we're going to do is we're going to go ahead and define a brand new function, and we'll call it encrypt. This function will encrypt an existing database, and we're going to destroy the original as per what we decided above. So we're going to set our cursor is equal to self.ptconnect.cursor. Okay, then we're going to say cursor.execute. We're going to go ahead and attach database. Now this is all in the documentation for SQL Cipher, something that I'll attach below as well. We're going to call it encrypted.db, and we're going to basically coin that as encrypted key. And then I'm going to set this as just a variable that we're going to define in 1 second, and we're just going to say, close this out and say format, and we'll just call this key, which we're going to define in 1 quick second. And I just realized that I need to get rid of that over there. There we go. So now this is all part of the same string. Okay, so now we need a key that we don't have yet. So I need to go ahead and create a key somewhere. Now, just for best practice, I'm going to show you how to create a key in a different file, but I can just easily call my key whatever I want here. So I'm going to go ahead and clear this out. We're going to write touch secrets.py. That's going to create a new file here called secrets.py. We're just going to say key is equal to, and I'm literally just putting in anything here. Just have a little bit of fun, no spaces. And that's going to be our key we're going to use. Okay, we're going to save that out. We'll close it because we don't need it. And we're going to go here and say from secrets import key. All right, so now it's going to basically define key as a global variable, so we don't need to worry about defining it anywhere else. It's going to pull in that key value, and it's going to use that to encrypt. But we're not done our encryption function just yet. There's a few more steps that we're going to do. All right, once we've done that, we're going to go ahead and then select this basically to be exported. So we're going to say execute, then we'll say select SQL Cipher underscore export, and it's encrypted that we're going to go ahead and export, which is what we defined right up here. And my brackets are the wrong way here, so let's go ahead and fix that. Export encrypted, and then close that out with a semicolon because we obviously need that in our SQL statements. Finally, we're going to say cursor.execute detach database encrypted. And then finally, we're going to have to go ahead and open up a brand new connection. So now we're going to say self .pt underscore connect dot commit. And then finally, we're going to close our cursor. And then we're going to go ahead and destroy that original file. So os.remove, and then it's balance.db. So what this is going to do is we're going to go ahead and pass in our actual connection, which is the balance.db. We're going to convert that to an encrypted database with the key that we just defined. We're going to export that so that you're going to see that over here. We're going to detach the database. We're going to commit our changes, close the browser, and then this balance.db is going to get deleted. So now let me just make sure all this looks good. Encrypted. So that's misspelled. Let's add in the T there. Okay, so the rest looks fine. So let's go ahead and run this. So we'll say Python dbenc.py, and again, let's look out over here. Balance.db should go away, and I should see an encrypted.py or encrypted.db, sorry, just show up out of nowhere. All right, so encrypted.db is there, balance.db is gone. So in that episode, essentially what he was trying to do is take all of the documents, encrypt them, and get rid of the originals. And there's obviously, backups on servers, which we're not going to go through, but it's a similar process if you wanted to get rid of those as well. All right, so now what we're going to try to do is we're going to try to read this encrypted file. So we're going to use hex tools, hex stump, tac C. Then we're going to go encrypted.db. And now when we run this, what you're going to see is all that data that was visible to us before on this right hand side is all now encrypted. So there's nothing here that I can actually make sense of. Even the select statements and all that stuff has basically been encrypted. So all the information in that database is more or less encrypted without that key. Okay, so we're going to run this another way now. So we're going to run SQL cipher and run encrypted.db. Now when I run this and I say tables, for example, it's going to say file is encrypted or is not a database. So we know that it's encrypted. Even if I say select star from balance table, again, I get the same error. So obviously we know that our database has been encrypted and there's no other way to do it, or there's no way to open it unless I actually put in this key value here. All right, so now we're going to create a function in Python that'll actually open it by us inserting that key. All right, so now we're going to do two things. We're going to build a method in Python that's going to determine how we're going to open this, but also show you how to open this if you were just running this in Linux, for example, in the background. So let's go ahead and create this method first. It's not a big method. It should be fairly quick to build. So let's do this. So define, I'm going to say read encrypted. And then here we're going to pass in self. And then the function here is basically going to be read encrypted database. All right. Then I'm going to go ahead and define my connection here. So I'm going to say self.enc, which is basically encrypted, is equal to SQL cipher .connect, except this time it's going to be encrypted DB, and self.enc.execute. Now we're going to pass something called a pragma, and pragma is basically the key that we're going to be using. And again, we're going to go ahead and use a formatted statement here and say format and then drop in the key, which is just going to pick that up from the file. And then finally, I'm going to go ahead and print the self.enc.execute and our select statement, because I'm going to be selecting everything basically. So select star from balance table, and that's it. And then we're going to just cap it off with a fetch all. All right, so let's just double check everything. And it looks like I spelled pragma wrong very quickly, so let's fix that. Now the other thing I just realized right now, without even running this, I know I'm going to run into this, is I put this connection, this initialization of the balance.db in the init function. As a result, I probably shouldn't have done that, but as a result, it's going to go ahead and create this time a blank database called balance.db. So just to mitigate that and not having to change the entire code, I'll just type in another command here that says os.remove balance.db again. But the second time it's going to open, it's not going to be a plain text database. It's just going to be an empty one because we're not passing any data into it anywhere. Okay, so let's go ahead and run read encrypted. So I've already changed the method. So Python dbenc.py, and we have an error here, and the error is my select statement. I probably spelled select wrong with two E's, so let's change that as well. And again, select. So there you go. So now we've read that encrypted data. So what happens if I actually set my key to something else? So let's say I actually set my key equal to, I don't know, 1, 2, 3 or something like that, and I got rid of this format statement. So let's get rid of this. If I did that, what it would actually go back and do is it'll say invalid key. It's probably because of the way I wrote it, which it is. So let's just change this to this 1, 2, 3, and then single quote. Rerun this again, and now it's actually going to say file is encrypted or is not a database. So that's because we passed in the wrong key. All right, so I added back the format just to make it all the way it was before. All right, now I'm going to show you one last way to do this, and that would be to actually do this through the command terminal completely. So that's encrypt the database through the command terminal. Probably what a true hacker would do. They wouldn't go and build a Python command for it, but if you want to build a program for it, sure, you can do that. All right, so now we're going to go ahead and actually do this through Linux. So I'm going to type in SQL cipher and then encrypted.db. Okay, so again, opens up an SQLite command. When I hit tables, remember last time what happened, it says it's encrypted. But now if I type in pragma key equals, and I go ahead and paste this, like so, that's the key that we had defined. And now when I hit tables, well, now it actually shows balance table because it's accepted the key. So select star from balance table. And now you have the data there again. And now there's one last thing to do, and that is for us to go ahead and delete that secrets.py file to remove the encryption keys. So we'd go os.remove secrets.py. So let's run this. And now that secrets.py file is gone. If I try to rerun this again, it's not going to work because there's no secrets file. So that is the conclusion of what we were trying to accomplish today. So that is how you go ahead and encrypt different files. And remember, I did this entirely on my iPad using my code server VS Code that is sitting on my own personal server. If you're interested in understanding how I set that up, leave me a comment down below and I'll be sure to address it. You can put this on a virtual server like I do. I use Linode and I also have servers on DigitalOcean. And for like $5 a month, you can put code server and you can put Jupyter Notebook and still run a website completely fine, no issues. Or if you want, you can go ahead and put this on an older computer or like a Raspberry Pi and then just SSH into it using a VPN connection if you're away from home. So very easy to do. So this is proof, this is evidence that I can fully code and create something quite sophisticated like an encryption algorithm just using my iPad. And the best part about this is when I leave wherever I'm coding, if I leave this midway, I can jump back on a computer and it'll continue exactly where I am. I don't have to go through GitHub and like pull requests and push requests and all that stuff. This is so much easier. It just saves where you are. And if I'm going to go back on the go again, I can quickly grab my iPad and it's there for me to code. So guys, hopefully you enjoyed this video. If you did, please consider liking and subscribing, and I will see you next time. Thanks very much. Bye-bye.